Okay, so our next one, we'll do our covalent ones. So we have polar covalent and non-polar covalent. So we can call our covalent ones our dating scenarios. Okay, so this is where we're going to be sharing electrons. So keyword, sharing electrons. But one of them is going to be an equal sharing of electrons, and one's going to be a non-equal sharing of electrons. So you know how like everyone has their pet peeves? Like, I don't know. I can't think of it. What's a pet peeve?
Leaving the cap off the toothpaste.
Yes, okay. So when you're peeved, are you happy or are you sad?
You're unhappy.
You're unhappy. So this is how I kind of came up with it, is you're peeved. If you're peeved, you're sad. If you're not peeved, you're happy. So, if you're not happy, do you think this is going to be an equal sharing or unequal? Probably unequal, which is making it sad. So, unequal sharing of electrons. A nonpolar covalent bond is going to be an equal sharing of electrons. So just knowing these three makes the test pretty easy if they're going to have you matching definitions. If you see the word unequal, boom, which one do you know it is?
Polar covalent.
Polar covalent. If you see a complete transfer, you automatically know it's ionic. Okay, so if we want to do examples, they probably won't have examples on the test, like they want to give you something and make you match it to one, unless it was this, because that's kind of more, goes along with the definition. But just so you know, if we're going to do a polar covalent, it's an unequal sharing of electrons. So a good one for that is H2O. And is it delta positive? So these two signs, delta positive and delta negative, it's a delta positive sign. That means that this side of the bond is having more of a pull. These two hydrogens are kind of pulling on oxygen more than oxygen's pulling on them. And then on this side, we're going to have more of a negative pull compared to the positive pull on this side. So if they were, just to give you this picture, just by the delta signs, you would understand, oh, if one has more of a positive pull, one has more of a negative. They're obviously not equal, right? So you know, okay, that's going to be a polar covalent bond. Compare and contrast this to if I give a carbon, 4 hydrogens. If you look at that molecule, you can see, okay, it's pretty symmetrical. We don't have any delta positive or delta negative signs. So you can say, okay, that one's probably going to be our nonpolar, because it's equal on all sides.
Awesome, okay, that makes sense.
Mm-hmm.
And will it have to have a delta sign to know that there's a greater pull on one side? Like with that one, you just see there's 2 hydrogens and only 1 oxygen. Is it safe to assume that there's a delta positive with the 2 rather than with the 1?
Meaning?
Yeah, so if you just erased all the deltas, could you just look at that and say that's a nonpolar covalent bond?
For this class, they want to do that just because we
Okay.
haven't studied chemistry that in depth. But the reason why is if you go back and we were to count the electrons and kind of bind them together,
Okay.
we'd be able to figure it out.
But they will give us the delta signs just to...
Yep.
Nice, okay.
I think this would be a little advanced for this class just because it's not a chemistry one.
Okay.
They'd more probably go with the definitions. But yeah, so you know it is, and the reason why this is nonpolar is because of the electrons and how many electrons can go to each hydrogen to make it equal. Okay, and then we have our hydrogen bond. And this is, your keyword that you look for is an attraction. Your scenario for this one is just an attraction. You're sitting guys, you're like, oh, he's kind of cute, or she's kind of cute. That's really all that's going on here. So, by hydrogen bond, the best example would be two water molecules being attracted to each other. So we have H2O, and then over here, how do I want to draw this? How do I do this? So I have two water molecules, right? And then I'm just going to give an attraction. Attractions are written in dots. Notice this is a bond. Attraction. So this is why if I go fill up my water bottle, how there's that like little bubble at the top. Because all the water molecules are kind of like trying to hold on to each other. And as you tip it over, then it like falls off. Because it's not a bond. It's not like salt. When you're like pouring salt on the table, it's not like all of a sudden it just like falls apart and sodium goes this way and chloride goes that way. They like stick together. They're married, they're bond, complete transfer. This one, they're just like, oh, I'd like to sit next to you in class, but if you don't, I'm not going to go out of my way to be like, oh, I'm going to scoot down all this way and follow you. It's kind of like, oh, there's a little attraction.
So those three dots, that always just means attraction?
Yep.
Okay.
Yep, so that's what's going on in this picture. That's a hydrogen bond.
Oh, sweet.
Notice it's the delta positive side of one of them and the delta negative side of the other. They come together. Remember when we did our polar bond and we said this was the delta positive and that was the delta negative?
Yeah.
The delta negative is on the O. So because that one's negative, that one's positive, they'll form that attraction.
Ooh, okay.
Okay, so there's all your bonds.